The Pearson product moment correlation coefficient, often simply called the Pearson correlation coefficient or Pearson's R, is a measure of the strength and direction of the linear relationship between two continuous variables. It ranges from -1 to 1, where +1 indicates a perfect positive linear relationship. As one variable increases, the other also increases proportionally. -1 indicates a perfect negative linear relationship. As one variable increases, the other decreases proportionally. 0 indicates no linear relationship between the variables. Advantages: simplicity. The calculation and interpretation are straightforward, making it widely accessible. Widely used, recognized as a standard for determining linear relationships. Disadvantages: assumption of linearity. Pearson's R only measures linear relationships, so it may not capture nonlinear relationships. Sensitivity to outliers. Outliers can disproportionately affect the correlation coefficient. Application in educational management (MEM). In educational management, Pearson's correlation can help administrators identify the strength of relationships between variables, such as attendance and academic performance, or teacher-student ratios and student satisfaction. By using Pearson's R, educational leaders can make data-informed decisions, helping to allocate resources where they may have the most positive impact on student outcomes. The coefficient of determination is a measure that explains how much of the variance in one variable is predictable from another variable. It is derived from the Pearson correlation coefficient, and its value ranges from 0 to 1. Regression analysis, explanation and importance. Regression analysis is a statistical method used to understand the relationship between one dependent variable and one or more independent variables. Essentially, regression analysis helps estimate or predict the value of one variable, the dependent variable, based on the changes in another variables, the independent variables. Key points of regression analysis. 1. Purpose. The main goal of regression analysis is to find the equation that describes the relationship between the variables. This equation can then be used to predict the dependent variable's value given the values of the independent variables. 2. Dependent and independent variables. Dependent variable, the outcome you're trying to predict or explain, e.g., student performance, sales revenue. Independent variable, the predictor or factor that is believed to influence the dependent variable, e.g., hours studied, marketing spend. Types of regression. Simple linear regression involves one independent variable and one dependent variable. Multiple linear regression involves two or more independent variables to predict the dependent variable. Nonlinear regression deals with more complex relationships between the variables, where the change in the dependent variable is not proportional to the independent variable. Uses of regression analysis. Prediction. It is widely used to make predictions about future data based on past trends. For example, predicting a student's future grades based on the number of study hours. Forecasting. It can help organizations predict future outcomes, like sales performance or employee productivity. Relationship understanding. It helps researchers and analysts understand how one variable influences another, for instance, understanding how a teacher's experience impacts student performance. Advantages of regression analysis. Predictive power. By finding the relationship between variables, regression analysis enables accurate predictions, which can guide decision-making. Quantifying relationships. It helps quantify the strength of the relationship between variables, providing a measurable understanding of how changes in one variable affect another. Applicability. Regression analysis is versatile and can be applied in various fields, including business, economics, education, healthcare, and social sciences. Disadvantages of regression analysis. Assumptions. Regression analysis assumes a linear relationship between the dependent and independent variables, in the case of linear regression. If the relationship is nonlinear, the model may not be effective. Outliers. Outliers or extreme values in the data can significantly affect the regression results, leading to misleading conclusions. Overfitting. When too many variables are included, the model may become overfit, meaning it describes the data too well and loses its ability to predict future values accurately. Applications in educational management (MEM). In the context of educational management (MEM), regression analysis can be used in various ways. Predicting student performance. Educational leaders can use regression analysis to predict students' final exam scores based on variables like attendance, study habits, and participation in extracurricular activities. For example, a regression model could show that for every additional hour spent studying, students' test scores increase by a certain amount. Evaluating teaching effectiveness. Schools or educational institutions can analyze how different teaching methods, independent variables, affect student learning outcomes, dependent variable. Regression analysis can help in assessing the impact of teaching strategies on student performance. Resource allocation. Educational administrators can use regression analysis to forecast the impact of resource allocation, such as funding for special programs, on student success rates. This could help in determining where to invest more resources for the best outcomes. Improving student retention. Regression analysis can be used to determine which factors, e.g., student engagement, access to support services, predict student retention rates, helping school leaders make data-driven decisions to reduce dropout rates. Conclusion. Regression analysis is a powerful tool for understanding relationships between variables and making predictions. In educational management, it can provide actionable insights that help improve student outcomes, optimize teaching methods, and inform resource allocation decisions. By applying regression techniques, school leaders can make evidence-based decisions that positively impact the educational experience.